Welcome to Products Board Architecture Meetup. We're going to be talking about something controversial to some, a topic of love and hate, topic of pragmatism and theory. We have three great guests today here. We have Tomáš Řehoř, we have Tomáš Růžička, and Roman Pichlik, who have a diverse set of experiences, both successes and fails. So we're going to be talking about those for about the next 40 minutes or so. There is a Slido link and a QR code right behind me over there. Find us. If I see questions coming from the audience, I'm going to flip it into a more interactive format. So definitely fill those questions out. I'm going to try to make as much space as I can for them. And that's why we're here. You're interested in the topic. You want to hear some answers. So ask the questions and you'll at least get opinions. So I'll let our guests introduce themselves. And, beyond what's your name, what's your role, what's the company you come from, in your current stack, in the app you work with today, where are you on this scale of monolith to microservice? Do you call them service-oriented architectures like the old days? How many people are working on them? So just give us a sense of scale of where you're at today.
Okay, so I'll start. So my name is Tomáš. My background starts from Skype, Microsoft, Pipedrive. Those are probably the most important experiences. And I've seen mostly transformations from monolithic application to services or microservices. So that's what my background is. This is what my experience will come from. And about our current stack, right now I'm at a very early stage, very small startup called Zenbase, and we have a monolithic architecture. Although when we were debating it on the way here, if we are using cloud functions and serverless architecture, actually each of these cloud functions is independent deployment. So is it independent service? So I think it's not just it's not monolithic in that pure definition of the term, but it's for sure true.
Yeah, I'll continue. Hello, is it better? Okay. So I work at Product Board for 9 years now. So it's been a long time. Previously, I did also some startups that you probably will not know what they're about. But I would actually say that throughout the history of Product Board, I also was part of sort of breaking the monolith. But I would dare to say that I'm also now part of merging the services. So I think I also have a little bit of perspective on the sort of step 2 of the step 3 in terms of building microservices. Yeah. So I'm somewhere like in between. I have not probably seen the most perfect microservice architecture in the world, but I've seen some. And yeah, most of my experience is largely from, let's say, quickly scaling a startup. So I haven't worked at a corporate or anything bigger than that. Yeah, that's for me.
So hello. Hello, everybody. My name is Roman Pichlik, aka Dagi. I first met microservices, I believe, in 2013 when the microservices was hot topic. I think it's still, true even now, like almost 11 years. After it, I went through a couple of the startups, scale-ups, working on fintech. And in all the companies, I met to some extent, microservice architecture. In most of them, we went from the, let's say, monolith, center of the world, and we're trying to somehow refactor towards microservices. In some cases, was very successful. In some of them, not. So let's share also the lessons learned. At Atacama, we are on the way from, let's say, monolith to, I wouldn't call that, pure microservice architecture, and we can later on talk what we, imagine, what is microservices to each of us. So we are on the way from, let's say, monolith to more like service-oriented architecture. And the engineering size, maybe it might be, interesting to hear. At this moment on this journey, we have around 120 people consisting product and engineering. So 120, something like that.
So to get a sense of scale from the audience, who's in an engineering team? Manager, architect, engineer, okay, most of us. Who works in a company that has less than 10 engineers? Who works in a company that has up to 50 engineers? Okay, who works in a company that has over 100 engineers? Okay, so we got, you know your audience now. A little bit of each. Who here has who here works in a company that has a microservice stack working in their company? Not a lot. A little higher. I haven't seen anybody. Mix. Okay, successful microservice deployment. There's more hands than the previous answer. I'm confused. Who here proudly operates a monolith? What are all the others doing? Help me out. What's in between? Okay. Who's operating monolith? Not proudly. That's true. I would then count it as microservices, I guess, since you'd have to deal with the issue. No, but that's good. So we know a little bit about our audience. Maybe tell me the last time you were standing in front of an architectural proposal or in a company or a strategic document that had the fork in the road, whether how your service architecture should look like, how granular should it be, how separated should it be. When was that moment, and how did you approach that? How did you approach that discussion? Who started the discussion? How did you evaluate? Was it just organic? Was it a conscious decision? And if you feel one more in the past is more relevant, feel free to switch to that one. But what's the last time you've stood in front of that decision, and how did you handle it? What would you do differently?
Yeah, this is great question, Vito. So I would say it was like 6 months ago, maybe 8 months ago, when we decided that we need to, we call it satisfy from SAS, so making our software more cloud native, running as a service. And obviously the topic was how we will cut the monolith into independent services. And one good thing was that nobody was using the word microservices too heavily. And for me, red sign of any discussion is if we start from not what we need, but from what is the output of the whole effort. So my let's say red lights start blinking every time when I start reading any proposal and very first sentence contain word microservices or microservice, because it shouldn't be very first thing that should be treated. So for me, one of the lessons, even through my past career, is we should start from what we need to achieve and why. And microservices may not be the let's say the final state.
But so I'll still keep the mic. How did the discussion start? Like, who triggered it, and what was the problem you were trying to solve? In your case.
Yeah. The the problem that we tried to solve was how we can enable the teams, how we can help them to make a transition from the monolith to the way or to the state when they can independently develop, test, and deliver software. So it was the right discussion. It was about how we can achieve that, and then obviously the microservices or the services itself, splitting the ownership was the the knife or thing that we use for driving the discussion and all the technical decision forward. So one example was, or one question was, should we first focus more on the zero downtime upgradability of the code, or should we more invest into decoupling of the code out of the monolith? And for good reason, and we can discuss that later on, we decided that the bigger, let's say, advantage at that state was like focus on the zero downtime upgradability of the component, because we can buy some time to learn other additional concepts which are important to microservices, like how we deploy it, how we test it, how we can ensure that nothing won't break, and etc.
Thanks.
Yeah, so for product boards, I would say it was around like a year before COVID or something like that. We had, the whole company was, I think, something around 200 people. And we were anticipating growth, right? And COVID happened and we were still growing as crazy. So at the top, we scaled to like something like 600, whereas engineering was, I think, like a third of it, something like that. And so the first time we've kind of looked at microservices was when we started like seeing some like organizational issues, in the sense of like not a single engineer can know the whole code base. Not a single engineer is going to understand it. It's just not feasible anymore. Same goes for teams. So we were aiming for, as Dougie was kind of saying, like kind of having ownership of clear parts of the code base, which we imagined would translate into this awesome world where you can do anything you want within your team and there's no problems whatsoever. So, at the time, microservices was kind of like this, let's say, a little bit of hype train, I would say. So we hopped on it. So to your question, if it was a conscious decision, I think it was conscious. But I would maybe experiment a little more next time before I would go kind of overboard with something like that.
And so you also mentioned, or if you also mentioned that you're merging, so it seems like
Yes.
you're actually on a,
So
your cycle is entering its second phase. Was that the pivot point where you like stop decoupling and you start coupling again? How did that go?
yes. So during COVID, we scaled, like I said, and post-COVID, we downscaled. And so I think that's one of the main drivers for us, the organizational complexity. But at the same time, it's not just that, right? Because like COVID times were really crazy, right? Like we were not a remote first company, even though we were compatible with like remote people. We were not remote first. And so there was a lot of like, the culture had to adjust to the new situation, right? And so, people didn't meet. We hired people who joined and left during COVID. Like, can you imagine? It's like you haven't met any of the people in person. It's a completely different environment, and in that environment, extremely difficult to spread knowledge, spread good practices, spread the culture, and so we just made a lot of services with a lot of different opinions, and that just bites you in the ass down the road, because especially when you downscale, because now you don't even have the people who build it, and you're supposed to manage it with less amounts of people. So yeah, we just have to consolidate right now, and that's pretty much what we're doing. So let's say 2 years back or something, there was another proposal. I think you were there, where we've drawn the architecture on the whiteboard, and we just said we were looking at 3 pieces. We separated the whole architecture into 3 pieces, which was already a big deal to just draw 3 boxes instead of 50. And we were looking at it, and we were like asking ourselves, what's the difference between those 3 boxes? And in the end, we didn't find that many. And so we said, yeah, we're just gonna put it in the same place. Everything from now on is gonna go to the same place. We call it PB Universe. It's a mono repository with like a, I would say, modularized monolith, because we've learned already that modules is what you actually want. Yeah, and everything new that we're building pretty much goes into that modularized monolith right now. But we still keep also the sort of OG Ruby monolith around as well. So I kind of call it like a symbiotic monolithic architecture. We have like 2 symbionts that know of each other, which is not a big problem when you have only +1 to talk to. But if you add more service into microservice architecture, it's like n+1, right? That's crazy. Yeah, so that's where we are.
You wanted to add something, Dagi, to Tomáš's point?
No, I just wanted to mention that every time the trigger for the getting to the microservice architecture was when my team or the whole organization, I mean R&D organization, was growing. So when we start seeing that people step each other on the tools, and we weren't able, for example, having clear responsibilities related to on-call duties, etc., was clear sign that we need somehow redesign and start, cutting the monolith. So for me, every time when I grew the team from 5 to 15, from 15 to 30, from 30 to 50, was like no brainer to do anything else, because I am strong believer that the monolith cannot be done in a way that it scale with, or I never seen it, and like I would love to be wrong, but I never seen any monolith that would scale accordingly to the size of the organization. So for me,
Would you be able to talk numbers? So like, what would actually be like the limit where things start to break?
I would say like maybe 15 people.
I'll give you actually a very different kind of story, and it's actually quite old as well. I think it was maybe like 15 years ago. And the reasons for this debate, what are we going to do about the architecture, was not driven by technology at all, but it was political. It was at Skype, and the entire backend was developed by maybe 50 developers, and it was monolithic backend. And then there was a political decision that part of the features will move from Estonia. Skype was at that time very Estonian-centric. It will move to the US. And of course, nobody in Estonia liked it. And in their very own subtle way, they were very politely, completely ignoring the American side and offered no cooperation whatsoever. And I know it very firsthand, even though I was not at that high levels at the time, but I was offered relocation to US as part of this decision. So I actually moved to the US, and one of my first tasks was actually figure out a way how we can start developing on this on the part of the monolithic code base that we are supposed to own, that we are not granting access to. We were not able even to deploy because everything was in Estonia. So we started thinking about creative ways, and at the end, at that time, the most simple and the most pragmatic way how to achieve what we needed to achieve was just simply put just stupid Nginx gateway in front of the monolithic application, and just URL by URL copy paste whatever was in the monolith. We created our own repos, we created our own deployment, and since we control the Nginx config, this is how we kind of got control of the code that we are supposed to own at the first place. Later on, it was proven that it was a very healthy decision, and the rest of the company started onboarding this setup. And at the maybe 1 or 2 years later, the monolith was almost completely gone, and it was split into different services. But the original motivation was purely political.
So I like the political one. It's maybe related to convey law and the organization setup and its evolution. Maybe I can add a couple more. So for example, when I was in Zonky was a peer-to-peer lending platform, and a trigger for us for particular part of the system was we cannot scale independently different workloads. So back in time, Zonky had a marketplace when loans were popping up and people could invest into it. But there was a huge demand of the investment, especially for the loans with high interest rate. So back in time, we had monolithical, and when such a loan appeared on the marketplace, people were in a rush, get their money into it. But we had the monolith, so every single login start overloading the whole system. So at that time it led to the, for example, back office team couldn't work on the another loans. People who wanted to lend the money couldn't because the monolith and the load on very single particular part of the system, which was the authentication module, overload everything else. So if you see this, mix up of the different workloads and you have the pattern that you have to scale for whatever reason the workloads independently, that's also I would say kind of the good trigger and let's say indication that you should start thinking somehow about splitting the monolith.
Yeah, I just wanted to ask you a question about the performance problems. So was it mostly like on the application layer, or did you also have problems on the database layer as well?
In this particular case, it was purely on the application level because there was some kind, I don't know, hashing function or so, which was fully utilizing the CPU. So the whole application was that.
The reason I'm asking is that's maybe going already into maybe some possible next questions, which is like, what's actually a microservice, right? Because like you, for example, said that you cannot imagine scaling monolith with different workloads. I would not probably agree with that. Because like, I guess it goes to the definition of the microservice, but I can like totally see how you can just have different deployment configs for a monolith. We've actually been doing this for a long time. It's basically you either pick endpoints or you pick pieces of functionality, and like you can scale it basically completely independently. But like, again, that goes back to the definition of what actually is a microservice.
I want to respond to that. I have a perfect example what I experienced at one of the companies I've been at. I'm not gonna name them, but there was this huge Ruby on Rails monolith, like really huge. When you wanted to run all the tests on your laptop, it would run for 48 hours. Of course, it would crash between it would finish, but that's how long it would take. Deployment would take forever. And still, there were these like two sides. There were the core believers into the monolithic monorepo architecture, and they were trying to figure out a way how to create a system of plugins and separate deployments of the monolithic application. And while they were having this academical discussion for a year, the rest of the company, meanwhile, started chopping off like pieces of the monolith and building microservices before. So before the academic discussion came to conclusion, oh, this is how we want to do it, like half of the company was already on microservices. So I think that's my point of view on services. The kind of the network boundary that is paramount to individual services is so powerful that it helps you with decision making. While when you have a monolithic architecture, there are so many options how you kind of chop it to pieces that before you make an agreement, the world is already in a different decade.
I got two questions in that regard. So the first one is, okay, let's say you're a VP of engineering and like you're creating some tenets or strategy for your team. And like one of them is like, do we allow decoupled independent services or not? Do we go with monolith? I think that's a strategic decision that should be made like very clearly to the whole company. Imagine you do and you say, okay, we're going into sort of a service-oriented architecture. Teams will have will operate different services. What are sort of like key constraints you would put on the system with your past experience? So you can build a new service, but, and then, you know, you can like have a few demands. What would be the top demands you have?
You want to go ahead?
Like also based on my experience, you know, when you talk with your engineers about microservices, the most common argument is, hey, Dagi, we can write a given microservices in whatever language we think would be best for the purpose of the microservice, which sounds great if you optimize for the local minimum. But from my perspective, VP of engineering, this is total disaster. So for example, when we start our journey, the cloud native product, the first constraint that
Oh, this one also dead. This one's alive.
very first constraint was, okay, we stick with two programming languages. One is Java, one is Python. I know that some of the people who were in, you know, who felt in love with Go were very sad. But I said, okay, from the perspective of hiring and ability of, you know, shifting people from left to right, we have to be consistent. So one of the constraints or boundaries was like, okay, we can write microservices, do your best, but please Java or Python. But whatever you pick, just please constrain this, because my past experience from Good Data, it was, you know, free from call. So we had Ruby, Python, Perl, Java, Erlang was terrible mistake. So for me, this is very first constraint that we put into our cloud strategy.
What other demands should we have?
I can comment also based on experience about the constraints. Basically, at some point when your tooling around managing your services is elaborate enough, adding another technological set is very expensive. Basically, you need to build a lot of tooling around supporting new set of technologies. So I remember that at Pipedrive, at some point the organizational structure was so decentralized that the individual teams were free to choose the technology they want to build and deploy their services with, but they have to also kind of invest into the tooling to support it. So that was kind of the constraint that the top level management said, you can do it, but there is a cost associated with it. So choose wisely which technologies you are going to implement. I will just finish it how it actually evolved into the future as the company grew. And there were still many opinions on what is the best tool set. At some point, there was actually like top level decision. These are the set of technologies we are going to support from now on, and the rest will become deprecated. So when there will be some refactorings, we will refactor it to the new technologies, or we will let them rot.
Because I think what I've seen is the problem is like the team even invests into tooling and it's perfect and it's fine, but you stop investing into that product area. You don't have no new development and you want to shift the folks to some other place and just kind of decays. And the dev who liked the Python stacks no longer there, and it just kind of keeps decaying. So that all, like, even if the team like fills that commitment of taking care of tooling, the flexibility around the individual stacks is something I've seen has been an issue.
as Tomáš said, and I would like to stress it out, it's also very expensive. It's very expensive, decision. I mean, like you start building all the capabilities that you need for the successful development of microservices, like mocking for the testing. You need, kind of the security around it, securing the build chain. You need to invest into the DevX and supporting the developers and broader technology stack you have, the more you have to invest into it. So it will stay with you and you will pay this debt like forever.
Yeah, maybe with the first part, I want to say, maybe I'll talk to the folks who raise their hands for like until 50. I would tell you don't do microservices, okay? That's the first one, okay? Right, let's go with the next one. So when to introduce them and how exactly, and how much standardization, pretty much the question is about, right? I think that in general, it's a little bit of, it's not intuitive, but the more standardization you add, the more freedom the engineer is going to have. It's not intuitive, right? But like, if you can agree on certain principles, maybe even libs that you want to use. So for instance, in our case, when we were starting out with the Kotlin stack, with the new monolith, so we were facing, right, like, do we go like kind of native Kotlin way of doing like libs and like, gluing it together, or do we just take Spring, right? We had really good experience with like all the frameworks as Rails, which was the original monolith. So we just picked Spring in the end. We had a little brief moment of like excitement. So was it HTTP4K or something like that? But that, yeah, we implemented it like 3 months or something, and then we found out that it was just the one team knowing how to work with it, right? So why would you do that? Why would you constrain your engineers shifting between code bases, exchanging knowledge, teaching each other? Like that's just doesn't scale basically. So like, and that's kind of my final point that I want to make is like, actually, so if you go with the more monolithic approach, that's a forcing function actually for you to use less stuff, right? So like you kind of constrain it. Again, it's a trade-off, of course, but like that's why I think the power of it is that many of the standardization questions are actually baked in to the architecture design if you go with a monolith. And I would say sometimes monolith comes with like a negative connotation. I don't know why. I would actually flip it. I want to flip this. I want to flip that microservices should come again with a negative connotation, because they come with so much cost. And like if you don't have the right experience and the right folks, the right tooling, and all the right environment to run them, you're just gonna die.
So if we stay practical, right? So these are the complexities. Like, and again, you're the VP engineering and you have your demands, the constraints. What else is on the list? So we, short list of languages, invest in developer tooling, don't go off the beaten path, choosing experimental frameworks. What else is there? Like, even if we get a little technical, what do you think is on that list?
So in our case, for example, we even decided that Postgres is the default database, like database in general, right? Like unless you start doing something super specific, something that needs a lot of data, maybe you go for some column database. But like for us, we're doing a SaaS B2B, enterprise app. It's not like we're not doing Twitter, we're not doing Facebook. We're also not doing now something data heavy that would need like ETL pipelines or whatever. So like relational database, it is. Postgres is pretty well established. It's also very flexible. There's a lot of plugins. There's a huge community around it. So it can cover like the sort of 80% of day-to-day, all of the use cases cover. And then if you think something about that, if you think about something else, we had like needs to filter through some documents. So we just picked, now it's called OpenSearch, right? That's it. So the database layer. If we go up the stack, in Kotlin, we picked Juke, which is a library, to run migrations out of database. That's just decided. We've also pretty much agreed on a repository pattern inside Spring. So just write classes to access the database over Juke. Yeah, and then it's Spring pretty much. Like this, I guess, I don't know, what can I add? Spring Boot, right? And that's the Kotlin stack right now.
Maybe what I would add to this is, you mentioned developer experience, but I found out that very few companies actually measure it. It's so easy to measure because it's so easy to count how many times developers spend waiting for their builds, for tests to run, for deployments. It's very easily measurable, but very few companies do. And when you start measuring and when you multiply it by number of developers you have, you can actually put cost on it. You can calculate how much does it actually cost the company. So I think this is a very healthy start when you try to make some very objective decisions, pragmatic decisions. Know what the problem is. And I just remember that probably around 4 years ago I was having a presentation at one of the Pipedrive meetups about CI/CD and continuous delivery. And when I was preparing for the presentation, I actually made up this 15-minute threshold, like a coffee break threshold. This is the time it should take for your build and tests and deployment to run. This is the time when the developer would finish, would kind of commit, push, and then they will go for a coffee break. And then when they are back, it should be done. There should be feedback whether it was successful or not, and they can move on to next thing from that. If it takes longer than that, you are just it just adds overhead with waiting for multiple builds to happen and whatnot. So that's what I would say. That kind of know what you are fixing, because only then you will know whether you are successful or not.
Maybe to your question, I'm still thinking the demands or constraints. And when I was working on our cloud strategy, one thing that I know that we have to absolutely fix is having the end-to-end ownership for the any change on particular teams, because before it, or even up until now, we have centralized operation team, and I know how this setup sucks. So one of the constraints that we put into it was you build it, you run it, count it with it since day one, because otherwise developers literally, get their hands out of the way once they commit to the master, which is
throw the artifact across
exactly. And then
across the wall.
It's problem of somebody else. I don't know. I don't care. So that's definitely constraint that should be placed in. Maybe one more point about when I wouldn't go wild with the microservices, and it goes back to my experience from Atacama, because prior to cloud version of our product, we are still selling self-managed version of our product. So customers can go download the Docker images and run this software on their premises, even within Kubernetes. And you wouldn't believe how complicated it would be if we have, hundreds of services, all the machinery that we would have to place regards to observability, yadi, that all the customers would have to adapt. Not mentioning that we are selling to enterprise customers, and they have their own opinionated way how they think the Kubernetes applications should look like and run. So they would be don't give a shit about how we envision that the application should be split, etc. So if you have this self-managed kind of the software, then you absolutely has to think about the composition of your application.
Because that's interesting, because with decoupled services, one of the first things that goes out of the window is developer experience, like running everything end to end. And imagine a customer has to do that, not a developer who you say deal with it, but you actually have to sell the product and keep the customers. I mean, you have to keep the developers too, but it's.
By the way, I would say the monolithic deployment is the best case for this self-managed, customers. They love it. Give me either one Docker image or one VM, and I'm super happy.
Yeah, I just wanted to add to the end-to-end ownership part that sometimes it's taken ad absurdum. I just wanted to draw a line and say that it doesn't mean that you don't need an infrastructure team. Like it just means that there should be a kind of a different contract between the teams, right? So in the classical setting of like throwing the work over the wall, it's like the ops team doesn't even know what basically they're running. They're just doing like config files and like they care only about, you know, replicas and all that. But in the sort of, even though it's not fully end to end, you can do like DevOps in the sense of having end to end ownership, but you don't have to do everything yourself. You can have a team who's going to manage your own in-house, let's say Terraform modules, right? So that the default configuration of Postgres is ready for you. You don't have to do everything yourself. You don't have to have a team that's going to understand everything on the planet so that they can run the software. That would be on the opposite of extreme, right? So when we're saying end to end, I think we're trying to say, like, let's say more kind of broad, right? Like going kind of through more of the layers of the whole stack, but not fully the whole way. Like for example, I've seen some design somewhere where people are just giving an AWS key. Maybe you guys can talk about it a little, but to me that sounds like a little too much, right? Like it would, like, unless I would have like thousands of engineers, that's not probably something that I would allow.
Yeah, exactly. So I would say like you build it, you run it. Doesn't mean that each and everybody has the admin account to AWS. And I'm full believer into platform teams. So for example, in Atacama we have platform engineering team and cloud infrastructure teams providing the layers. The actual functional teams can build their services. So definitely.
I would just quickly add to this topic that I think the key factor is self-service, that the infrastructure teams build the platform in a way that engineering teams can, in self-service manner, configure, deploy their services. They don't have to create Jira tickets or whatever tickets and wait 2 weeks for somebody to do it.
I used to call it supermarket development. It's like you go to the shop and a little database here, a little cache here, a little storage bucket here, and like you check out yourself. There's like self-checkout, not somebody.
Yeah, exactly.
Keeping your card. So I do agree with.
Basically, everything should be a PR away.
Let's move on to questions. We have more than 15 questions, so we're going to try to go through them. If you haven't submitted, submit, upvote. If you haven't, I think the QR code is still there. The first one is for me. So I work at Microsoft here in Prague. I actually work in a platform engineering team, so we're the supermarket owners. I can talk about identity. So that's like Azure Active Directory, the whole login experience that powers everything Microsoft, Office, Xbox, Outlook, whatever. It's about 2,000 engineers. Officially, it's about 150 services. It's usually pretty chunky services owned by a single team or group of teams. There's a very you code it, you run it sort of mindset. A software engineer does everything else but write code.
Sorry, when you say a team, can you be a little more specific?
A team is 8 people. A group of teams would be, say, 5 times 8 people, about 40. And you're the analyst, you're the developer, you're the operator, you're the QA, you're everything, and there's no role specialization these days. The services are built to be simple because they need to be scalable, so they're super stupid in terms of input and output. Typically, you try to avoid anything like SQL because it's inherently not scalable. So you try to go with simple key value databases and things like that. But again, then it kind of forces you to be simple because you manage so many environments. There's the thing, if you go to loginmicrosoftonline.com, it's a service called ESTS, secure token service called ESTS. That's a monolith where 300 people work, and I don't think it's particularly pleasant. If you launch a small little service, the moment you mark it as production ready, there's a compliance system which will tell you all the things your service needs to meet, and that list will make you sweat. And we were joking before the meetup that you don't get to see the checklist before you actually launch the service. So anyway, that's kind of the people know the cost, at least from their old service. So they typically, the one anti-pattern is sometimes it's easy to you need a feature and you need to slap it on somewhere. So you just kind of choose a service and just put it here because you don't want that added compliance cost, even though it could be neater separated. But other than that, larger services, usually 50 people or so supporting it. That's the drill. But you also do a lot less coding than you might be used to in a smaller company. Can you help me out? Just if you're guys somewhere here, just like remove the questions. How many microservices do you operate? How are they orchestrated? Kubernetes or something else? How do you keep the teams informed about the list of your services? I like the last question. Anybody with a strong opinion or a success story in that regard? From how many services do you have? How do you orchestrate them? How do you build a catalog? Anything you're proud of that you've seen or you felt inspired by?
Yeah, so for us right now, I would say sort of like the product services, I think it's lower tens, maybe we're even under 10 right now. That would be a major achievement actually. But like if you look at the whole thing, right? Like we have a Kubernetes cluster, right? And then you need a lot of different things around for the whole thing to work. Yeah, we're talking, I think something around 200 or something like that of deployments. So yeah, again, how you look at what is a microservice, right? Yeah, and like a question about the catalogs.
Yeah.
Yep. So for us, we tried Backstage for a while. That's kind of like a more self-hosted, self-run solution built by Spotify.
Is it any good? I heard mixed feedback.
Yeah, so I just wanted to talk about that. So again, right? This was one of those cases where, yeah, this is an amazing company. They're doing great stuff. They're doing microservices. Maybe we should do it as well. And as well as for us at the time, we were planning to have a lot of services, so it was valid to look at a tool like that. But at the same time, on the market, they're starting to pop up like all these specialized tools. So one of them being Cortex is one. Jira also announced something called Services Catalog, whatever it is. So yeah, they are already specialized. So like I would probably say like if you do not invest heavy money on your platform teams, you should probably buy. I would rather go with buy. We're actually discussing it internally as well to actually go with a buy solution rather than build.
What's the coolest thing? Who's the coolest kid on the block in terms of service catalogs these days?
In my mind, I always liked Cortex. So like, I was in touch with the team since the very beginning, and like it seems very feature rich and very kind of a lot of things are already integrated. A lot of integrations are just turnkey. You just put your API key in and it's done. Like they run it themselves. They connect to the GitHub repos, to your deployment, systems. It just works. They have scorecards implemented, all that. So, all the sort of jazz that you would want from a service catalog.
So now we are about like 20 functional services or microservices. The Kites is the orchestrator. So we are running on top of Kubernetes. I recall back in time in Valvon, a fintech bank that we were about to launch in Germany with the 70 people. We were on something like 120 microservices. To be honest, it was too much. At that size, we ended up with the homemade do-it-yourself catalog because it was before Backstage. So we had the templates in GitLab, and we somehow generated to some kind homemade catalog.
I can give two examples. Right now at Zenbase, I became a great fan of serverless architecture. We don't have a too shabby service. We have a lot of requests, a lot of logic going on there, and I was just checking our infrastructure cost for just the backend. We are paying $54 a monthly. We are only serverless, which is I think is amazing. But to talk about the other side of the scale, Pipedrive was a different extreme. There were like 600 microservices at that time. It was split between backends and micro frontends. So it's not that it was like 600 backend services, but it was a large number. And in terms of the infrastructure cost, it was a big topic there. Pipedrive was running their own data centers, 3 data centers, and their own OpenStack cloud on top of it. And I didn't see the calculations myself, but the CTO was claiming that just by running their own their own data centers with their own cloud would save them $500,000 a month compared to AWS. So I would say that's something to consider heavily when you have so many microservices, when you really like embrace the microservice definition and you go really wild. You have to pay for each container, and it's expensive in the public cloud. So maybe that's also part of the decision. Should we run our own hardware on data centers?
Main reason for microservices. We covered a little bit. I think we've heard a few reasons. But in your eyes, let me maybe shape the question. When you actually did decouple split and it actually solved the problem you had,
I would
it was
say
not a loaded question.
no, I wanted to say that there are more reasons when you should start thinking about it. One is definitely cognitive load. I don't know if you guys know what is cognitive load. It's how much of context you are able, to keep in your head when you are writing a code. So definitely cognitive load, which might be related to the size of the code base. So that's another reason. And for me, definitely blast radius. So if I'm checking in, what else can be broken? And the trigger in my case is usually the team size. So if a team grows, then I know that we have to split and go with maybe not microservices, but let's say services. And all these factors mentioned there, like for example, independent scaling of the load, independent of the deployment, blast radius, cognitive load. These are the let's say other factors that I usually use to support the actual split.
Yeah, so main reason I would in general say it's usually organizational problems rather than the technical ones. Even though, again, if you're doing something that's kind of outside of the normal in terms of architecture, if you're doing, for example, like extreme load or you're doing AI or something like that, there might be different reasons, technical reasons why you want to do microservices. But I would say for majority of the companies, it's usually organizational. I would also mention the actual org design that you have. I don't mean the chart necessary, but I mean more like the way how you want the organization to work, how you want the teams to collaborate, because the teams and the organization design is completely inseparable from the software architecture. You have to think about it as one thing. And so like if you're redoing one, you need to rethink the other part as well. So I mentioned it already, but like for us, it was mostly usually the organizational like reasons.
I think I can add only one reason that was not said yet, which is technological reasons. Typically, I've experienced that the team decided to spin off a new microservice just because they needed to build something using a language or libraries that were not available for the other mainstream technology. So let's say in Pipedrive, there was only one service using .NET because .NET at the time had the best library for working with SMTP servers, and IMAP protocol, which Pipedrive was using heavily. So that was the reason why they actually spin off the service.
That's my. I heard two things that resonate with me. One is optimizing for resilience, and to be honest, you can solve it with one code base. You just deploy it multiple times. You partition your data, and you have independent application tiers. That causes some problems because then you want the simplest stack you can have, because, for example, moving the data between partitions suddenly becomes a problem, things like that. Or you can optimize. You need to optimize for ease of data exchange. You need to be able to join all your data to all the other data. And that becomes a huge hassle. And both, I think this is one of the things where, what is the type of complexity in your app? There's others, but one is resilience, load. Another typical one is just this kind of connected, you're building a CMS or you're building a product board is actually a good example. All the data somehow related to all the other data. And when you're optimizing for these things, you kind of need to see, okay, how is my biggest problem going to look like in my future architecture? And what is my biggest problem? If main motivation is decoupling, aren't microservices just a well-behaved monorepo with extra network latency?
Maybe I can just start answering this one before you take all the good answers. I think I mentioned it at the beginning that microservices give you this great advantage of the network boundary, which is really hard to break when you're writing code. So I think that it just kind of helps you with decoupling by design, and that's the biggest advantage. You don't have to think about it that much. With monorepo, you have to think about it. I think it's already put there in the question, well-behaved monorepo. I haven't seen one well-behaved yet.
So it's again like a tool to enforce some behavior in the org, like the same way you did your Nginx. You just draw the wall on a network and it's hard to cross. Whereas a module, like I'll just import. One little import won't hurt me.
What can break?
Go for it.
I have no motivation to be fair. Do you guys?
Yeah, I guess I'm just gonna repeat myself, but like, you have to think extremely carefully if you want to do microservices, because if you start, you're opening up this Pandora box of all these decisions, all these stacks. The possibilities are endless. But like, I don't want more problems. I want less problems. And so I want less stack. I want the least amount of code. I want the least amount of people to do the job that I need to do. So like, I guess to this question, I would say yes. Yeah, but like, again, it goes, as Tomasz mentioned, it's about the definition of well-behaved, right? I think there's this great article online. I think the title is something like, you don't need microservices, you need modules. I think if you don't build a big ball of mud, right? Like just like, no brain, just like connect things with thing, and there's no system whatsoever. That's not a problem of a monolith. That's a problem of a missing architecture. And like, you can architect a monolith. So I guess that's the well-behaved part. So like, if you think about the modules, if you think about some sense of separation and how the modules should communicate, introduced a little bit of rules into that, I think you're going to do just fine for a long time.
We got it jumped a little bit, but we had two questions just a minute ago about documentation. One was about how do you actually document the whole thing and just capture the state, like capture the system. The second one was more specific. How do you document the relations between different services and connections? Do you somehow automate it? So do you actually have a picture of your whole ecosystem, like, printable? You might need a big wall, but do you actually have it on like in a form that you could print it on a wall?
I would say it depends on the detail that you need to see. But for our products, which usually operates with the most sensitive customer data, is extremely important to understand how the data flows. Looks like how customer data may travel from the perimeter of the customer and being stored in Atacama. So the level of the documentation, reflects this. So we need to be sure that sensitive customer data are exactly stored within some services that provide guarantee about, security, reliability, etc. So I would say, like, for us, the documentation driver is just for the sake for the let's say this ability to selling enterprise customers. Like for the developer needs, I don't think that's the reason. They usually don't care.
Is the tooling important here? Do you have any tooling tip, or is it
Notion and diagram drawn in, I don't know, like whatever fits to you, to whatever fits to your hands.
I would say that if you really mean it seriously with your service-oriented architecture and you really want to do it well, you don't want to have the headaches that are typically associated with it. It's really easy to automate what was behind this question. Like it's really easy to automate documentation generation. You can just maybe add some annotation in the code for each of the API endpoints, and then like all the requests between different services. This is very easy to automate. Like start collecting the taxonomy data and run some analysis on it. And I'm speaking from my own experience. Like the best working system I've seen was actually at Skype, and everything was automated. The documentation was generated, and all the relationship between individual services was collected in the analytics. And there were reports built. You were asking about, did we have a map on the wall? We didn't have it on the wall, but it was there. You could, at any point of time, you could see which service calls this particular service and which version. Even the services, the endpoints were versioned, and you could see how many other services are still calling this specific version of it. So it wasn't that hard to build this level of sophistication, but the gains were tremendous. So that's what I would say.
Maybe I'll just add one more tool to the mix. So we're actually relatively heavy users of Datadog, and like if you annotate your logs and services and metadata and all that, well, Datadog has a lot of cool features. One of them being, for example, the service catalog, or you can actually see even the traffic going through. If a service is failing, you can see the whole chain of what it influences. So that's not a documentation per se, but I think it helps with visibility a little. We still have a long way to go to not have any errors in it. But I think it's nice that, again, it's kind of automated. You can just see it. It's also in the runtime, so actually what's happening in production.
By the way, one interesting observation from my perspective, and that goes back to the never-ending, debate, monolith versus microservices. Guys, have you noticed how much is the ecosystem around, microservices is evolving comparing to how much have you heard about, a plugin system that would help you, to write proper monoliths? I would say you cannot compare it because everything, not maybe everything, but the majority of the focus goes into the tool chain and support of development microservices, which is also important argument that you may take into consideration.
We're reaching our time, and there's still quite a few more questions. I would leave them, unless you want to pick one of them. You go? I would leave it to the last piece of wisdom and leave the rest of the questions to networking, but just in case there's strong opinion on any of these.
Yeah, maybe I'll just answer the on-call one. I think we're doing a decent job there. So, of course, there are some historic reasons how it's built, but we pretty much have on-calls per service. But in our case, as I said, there's not many services. In certain cases, it's even, let's say, by a module or by an endpoint. And then we have, let's say, like a catch-all team that kind of knows most of the stuff. We call it application on call. That's where things get escalated if the team cannot handle it themselves, or if it's actually in the Rails monolith, because the Rails monolith is what the application team is also managing. So let's say it's like a 2-tier architecture. There's also a escalation for managers in cases where it's a security issue, or you need some key that's only sort of super secret, so you can call in a manager.
What about customer escalations? So first they go to support and...
We're using Rootly for that. It's a pretty nice tool. It automates the whole incident process. So once we have an incident, which is either triggered by some monitoring, or it's triggered by a person, marking P0 in a Jira ticket. Sometimes it happens on accident, but people. You just start an incident, and it's gonna help you manage the whole thing. So you can designate an incident commander who's gonna be the driver. It also auto assigns a support engineer who's gonna help you communicate that issue outside. And it kind of helps you to manage the whole thing. You mark when the issue is mitigated, when it's actually solved, and then it also pings you back for a postmortem, which is which is also a pretty important part of the incident process overall. So we always collect the feedback through the whole thing, and then we write it down, and then we have a call around it, and we discuss what are we going to do with it, and then we distribute the tasks.
Maybe last question, what about non-urgent escalations? Like I need to flip a switch somewhere that's not very well documented, migrate my data, do this batch upload because your API doesn't support it. Things you don't have a public API for.
So sometimes it's paid support for, I mean, not support, but professional services. So we try to shield the actual engineers who are on call from these, activities. But to be honest, we know that some of these activities need engineering involvement. So we have, let's say, 20-30% of the engineering team capacity for the handling bugs, helping with troubleshooting, or helping with such kind of the request. But it's not the rule of thumb is it's never handled by the on-call engineer.
Yeah, maybe I'll just extend on the idea of the Jira tickets. So as we have P0, we also have P1 to, I don't know, like 6. Each of the levels have their own SLAs, meaning like by which date they should be eventually solved. And based on that, basically, there's a whole process around like, the engineering managers are managing that to make sure that everything gets delivered. Also, for the actual engineers who usually handle these tickets, most of the teams settled on the shield agent model, where you basically just designate a single person for a week, let's say, who manages all this workload, so that you don't disturb the whole team, with these random one-off requests.
Yeah, maybe one more note to the on-call, and it's fair to say, like if you build it, you run it model with the engineers, being responsible for the on-call duties, it's pretty expensive fun. So you have to count with decent money for it, because it's.
You should pay for on-call. You should pay for on-call. Well, I'll leave the rest of the questions. We're going to stick around, all the speakers here. It's a big thank you to Tomáš, Roman. Big round of applause. Stay. There's food. There's drinks. Connect with people you don't know. Ask the group any questions. Try to welcome people in groups. And thank you for your attention. And a big round of applause.